Hello, in this video I'm going to explain about gravitational force, field strength and gravitational potential energy, and we're going to do few exercise on this topic. Okay, let's start with Newton's law of gravitation. So Newton's law of gravitation states that every particle in the universe attracts every other particles. So we have equation that express this definition to be F equal to G m1 m2 divided by r2. So we have two mass. Here we have m1 m2 and there's separation between the two masses. So we have r1 2 and there is a force exerted by mass 1 on mass 2 and also by mass 2 on mass 1. The direction of both forces are opposite towards each other, but the magnitude is the same. So this supports the Newton's third law. Next, the SI unit for Newton's law of gravitation is Newton, that is N, as Newton's law of gravitation refers to force. And G given in the equation represent gravitational constant, that is 6.67 exponent negative 11. Next we proceed with gravitational field strength, where gravitational field strength is gravitational force per unit mass of a body. Body is what we call as test mass. It is a mass that can be moved from one place to another place. So we have our big M and we have our small m. Big M refers to the mass of the planet and small m refers to the mass of the test mass. And there is the distance between big M and also small m. So equation for gravitational field strength is derived as shown in the video. So the final equation that we get is Ag equal to Gm divided by r squared, where G is gravitational constant, M is the mass of planet, and R is the distance between the planet and the test mass. And the unit for gravitational field strength can be meter per second square or Newton per kg. That is the graph that can be used to represent our gravitational field strength, inside the Earth and outside the Earth's surface. Where inside the Earth's surface, Ag is directly proportional to the distance, but outside the surface of the Earth, it is inversely proportional to the distance between the planet and the test mass. Last we talk about gravitational potential energy. It is a work done. It is a work done by external force to bring test mass from infinity to a point R. So the equation that we can use to calculate gravitational potential energy is negative Gmf divided by R, and the unit is joule. So let's look at the first question. PSPM 2009-2010. We have mass of Sun, mass of Earth, and we have the distance between both of Sun and Earth. So first we need to draw the force acting on both Sun and Earth. So we have the force exerted by Earth on Sun. We have force exerted by Sun on Earth. Both have the same magnitude but opposite direction. So we can calculate the value for the gravitational force between them by using gravitational force equation, that is Gmm divided by R squared. Substitute all the information given into the equation, then we will get an answer to be 3.53 exponent 22 Newton. Next question B asks to sketch a graph to show the variation of Ag from center to twice of its radius. So plot or sketch a graph of AG against R, make sure you write the unit for each of the axes. So inside of the Earth, okay, it is directly proportional, but outside of the Earth's surface, it will inversely proportional. Okay, so this is a method on how to sketch the graph. Okay, next we move to SPM 2011-2012, where we have three bodies here. So we have M1, M2, and also our M3. Okay, M2 and M3 are separate by 15 meter. Okay, so first sketch and label the forces acting on mass M1 due M2 and M3. So we have on M1 force on M1 by M2 to the left and force on M1 by M3 to the right. Okay, so next we need to solve to find our value of x when M1 experience 0 net gravitational force. So we have negative F21 and positive F31 based on its opposite direction. Okay, so this means F21 equal to F31. So we use equation for gravitational force. Okay, cancelling out all the similar unknown. So we just left with M2 divided by R21 square equal to M3 divided by R31 square. Substitute all the information given, so we get the final answer for x to be 6.74 meter. Okay, for PSPM 2007-2008, at what altitude from the surface of the Earth will the acceleration due to gravity be reduced by 10%? Okay, so we're going to have two positions here, one on the surface of the Earth and another one outside of the Earth's surface. Okay, so we want to find the altitude. So we have G2 and G1. Okay, we know that G2, the gravitational acceleration is reduced by 10% of the acceleration or gravitational acceleration due to the gravity at the surface of the Earth. Replace G2 and G1 with the equation that is Gm divided by R2 equal to 0.9 Gm divided by Re squared. Okay, so we get the radius, the distance from the center to the point, the second point, to be R equal to 6.75 exponent 6 meter. Okay, so therefore the altitude will be R minus with radius of the Earth. Okay, that's all. Thank you.